So, hey, good morning, everyone. Thanks for joining on a weekend to attend our sessions. Great presentation by Yogesh. So, our cluster is up. He has deployed a dummy application as well, the voting app, and he has got 100% in that with thumbs up. So, let's start with a little bit more in depth into networking concept. So, we would be discussing about network policies. Before we start with network policies, let's understand how does the networking work in Kubernetes. So this is my Kubernetes networking. So here, if I say this is Kubernetes network, Yogesh has set up a one master and a one worker node cluster. But here, if you look at this virtual machine, you can name it as worker one. And this virtual machine, you can name it as worker two for me. I'm not showcasing master node here because when we deploy our applications always get deployed in the worker nodes. They don't get deployed in the master. Master controls the cluster. It has etcd, the controller manager, scheduler, and other stuffs, which help us in managing the cluster. So here we are more focused on application deployment. So I would be focusing on application pods. Application pods could be an Nginx application, could be a database application like a SQL application, could be a Redis application. When we are deploying a multi-container or multi-pod application, how they interact with each other, that is our agenda to understand here. And if I have a SQL pod, imagine this pod 2 is a SQL pod and my pod 1 is a web pod. How would the communication happen? This is a single worker node. And if my application, both the application are deployed in the same node in the cluster by scheduler, then the packet which runs through. So this is the bridge network. We get the bridge networking done by Docker. So these containers are the pods which gets hosted. They get hosted on the bridge network. This is a Linux bridge. And this is the interface of our virtual machine. So here my IP address of the VM would be attached to. This is my network namespace for the host. And this is the network namespace for the pod. So every pod gets a unique IP address because it has its own network namespace. When we move from the world of Docker to Kubernetes, instead of containers getting an IP address, it's the pod which gets an IP address and containers get port number in that port namespace. So this is my web pod in which my web container is running. And this is my SQL pod in which my SQL container is running. It would listen on a specific port number and pod would get an IP address. This is my Ethernet interface of the pod. This is my Ethernet interface of the SQL DB. So if we want to communicate the packet when it goes out, the destination which is mentioned here, I'm not getting service into picture. So destination would be the SQL pod's name, which would obviously get translated to SQL pod's IP address by the kubedns which is running. So it would be SQL pod's IP address at the end. And when the packet goes out, it first falls on the bridge. Bridge looks into the destination IP. And because they both are residing on the same worker node, the IP address comes from the same subnet. So it understands that within this bridge itself, within my network itself, the packet has to be routed. And that's the reason it looks for the container or the pod, rather, I would say, my bad, the pod with the IP address and forwards the packet. So this way the packet would be flowing. So this is within one host. If the communication has to happen, it would go on the bridge and then come to the other pod to which the packet is destined. In case we are talking about two hosts, this is my worker node 1. Let's say my web got placed here and SQL has got placed here by the scheduler. Now my front end is willing to communicate with the backend. At that point in time, the packet, when it originates, it again goes to the bridge. And the subnet range on this worker node is different from the subnet associated to this worker node. So the bridge subnet here is different. It would say, for example, I'm just saying subnet A, and this would have a subnet B. So all pods residing on this bridge would be having IP address from this subnet, and all pods residing on this bridge would get an IP address from this particular subnet, which is a different subnet. So when the packet is destined for a different subnet pod, then the bridge throws that to the Ethernet interface. Here we have overlay network. Like in our case, we are talking about Calico. You have ViewNet, you have CubeNet. There are n number of types of container network interface which you can plug in. It's like a plugin. With Kubernetes, networking is it's not incorporated inside the Kubernetes itself. We can plug in the network of our choice by just applying their YAML files. So if you choose to apply Calico, you choose to apply Flannel, ViewNet, CubeNet, of your choice, you can do that. So here you would get that networking, and then the packet would go to the other node. Looking at this worker's IP address, the packet would be transferred to the other node. So how we would come to know that the packet is destined for worker node 2? Suppose the subnet B, which is there, worker node is associated to the subnet B. So any packet destined for subnet B would be first transmitted or forwarded to worker node 2. Here, there would be a component of Calico or ViewNet, which would be sitting. There would be a pod, which is the CNI pod, whose work is to translate the IP address from the pod's IP to the node's IP, so that when the packet is going out of the node, it would be having a destination IP of worker node 2. Again, there is a CNI pod sitting here, whose work is to remove that wrapper of the worker IP address, which is written. It would remove that particular encryption and then have the pod's IP address as the destination. And when that packet arrives on the bridge, it understands that the packet has to send to this particular pod. So this is how the pod-to-pod communication happens, whether it is on the same node in the cluster, whether it is on a different node in the cluster. By default, any two pod in a cluster can talk. There is no rules to deny the traffic. So it could be a front-end pod, it could be any other different application itself, because we would have a very huge cluster. It would just not be one single app I would be running on my cluster. So any pod to any pod communication by default is allowed. And that actually is a threat for us, right? Because we don't want any particular type of packet, any type of packet to be destined to our pod. We just want, like, for example, in this example, which I've taken the web and the SQL, I just want the web to communicate to the SQL pod. I don't want any other pod to communicate to the SQL pod. I need to build an intelligence between in SQL saying that, hey, SQL, if the packet is not coming from web, don't accept it. And if packet is coming from web, accept it. That intelligence, when we incorporate, that is called as network policy. So for that, let's get into this. Sorry, I had missed giving my intro itself, so no problem. So we can discuss about network policies. Network policies help us limit connections between pod. Any pod-to-pod communication is allowed, so we would limit the connections. One pod to other pod communication, we would be going ahead and saying that P2 can't talk to P1 and P3 can talk to P1. You would have allow policies, and we can have deny policies as well. So we would see different varied ways of writing our network policies. We are trying to secure our application using these network policies. We are trying to not allow any unwanted communication to happen with our application pods. And that's a reason it helps us in securing our application pods. And we use some kind, like Yogesh was showing kind deployment, kind pod. Like that, there is a type of resource in Kubernetes, like Yogesh showed, daemon sets, stateful set, jobs. Whenever any type of resource has to be created in Kubernetes, we define a kind associated to it. So kind network policy is a resource which we would be defining to define our network policies, and we will tag those network policies to specific pods. Let's see that. So here we would be having pods, and every resource in the cluster is normally labeled. Any type of resource when we create, we label it. I'll just take you to my cluster to show you something. So let me open a sample application file. So here we are creating kind deployment. Then we have a label associated to our pods. Label is App Nginx. So this label is used for identifying those resources so that we can attach our policies to it. So our intention is to first create a resource with a particular label, and using the label, identify the resource so that we can tag a particular policy to it. And that is what is meant in this. The network policies would apply to a specific pod with the help of label and selectors. There can be two ways of traffic, right? When, for example, P1 and P2, there are two pods. P1 communicating to P2 and P2 communicating to P1. So if I'm at P2, this is my ingress traffic, and this is my egress traffic. So we have two types of traffic. Egress is the incoming traffic, and ingress is the incoming traffic, and egress is the outgoing traffic. I can limit one of them, or I can limit both of them. It's our choice. I just want to limit the incoming traffic, then I'll apply ingress policy. If I want to limit the outgoing traffic, then I would apply egress policy. So we can define different types of policies, and we can attach it or tag it to our resource so that those particular policies would be applicable to the resource, which would be having a specific label. So we would be using label selectors for defining this. So let's see, how do we do this? Taking you back to the, let me just open up. I have taken few snippets and kept this ready. I would explain it here, and then we would go ahead and apply this policy to different resources which we are creating. So here, this is how a network policy is defined. Network policy is belonging to kind network policy. It belongs to this API version in Kubernetes. Every resource has kind API version, metadata, and spec. So metadata gives us metadata about this resource which we are defining. So we are defining the name of the resource. The policy is named. This is my policy name. And the specifications about the policy. This specifies the selector. We are saying this policy, which is defined here, would be applicable to the pod which matches label of app web. So there would be a pod labeled app web. This would be the label. This is not the name. There is a difference between the name of a resource and the label of a resource. Name is used for name to IP address translation. The DNS name would get generated with the name. Label is used for identification purpose of a resource. So here we have app web as the label. And when we say pod selector, this particular policy would apply to all the pods which are labeled as app web. And here, if you see, I'm using empty square braces. can see we have used in the last snippet, there are square braces. That means nothing is specified. When nothing is specified, that equals to deny. When we say, I have a policy, unless and until any policy is attached to app web, everything is allowed. By default, it is allow all. As soon as you attach a policy, suppose I'm attaching this policy to this, and in this policy, I have written empty square braces. That means that I have not specified anyone to talk to it. No one is going to talk. That's what is deny all. Let's try out this policy on the cluster. So I would be not using YAML files to create my resource. I would be using kubectl run commands to create the resource. How we have Docker run, like that we can use kubectl run. I would be creating a pod named web. I'm using Nginx image here. And I would label my application as app web. So this is the label for the pod. I would create service as well, because we know that when any pod-to-pod communication happens, because the pod's IP address are not persistent, a pod can't retain its IP address on reboots or recreation. And that's the reason we bring service into picture. So I'm using -- expose, so that service also gets created along with the pod in the same command. And I'm specifying port number 80 as the port on which the service would be listening. So I'm creating a pod with web, name web, with Nginx image. I'm labeling the pod as app web. I'm exposing it and creating a service. And the port number which would be used for communication is port number 80. Label spelling is wrong. Sorry, my bad. Yep. So here it has gone ahead. Let me do get all so that it can list the pod and the service both. So here pod web is up and running. Service web is also created. So I can go ahead and create another pod and see to it that my application is reachable. Here at present, no network policy is applied. So if I create any other pod, as we understood that pod-to-pod communication by default is allowed. So let me go ahead and use another kubectl run command. I would interactively get into this pod. I would use a plain Alpine image, operating system, the base OS image. The name of the pod is test, and I'm creating shell as the starting process inside it. I'm into the pods container. You can see the prompt has changed. I'm no more root@ThinkMakeMaster. I'm in the prompt, the shell prompt. So I would try to access my application. So I'll do a wget. I don't have curl on this, on the base operating system. Curl is not there as the package is not installed. So instead of installing curl, I'm trying to do a wget. I would try to reach the application with the name of the service. What is the name of the service? Service name is web. If I just do this, I should be able to reach my application. And that is because our clusters are divided into various namespaces. I have not created any namespace. I have not defined any namespace during the creation of the pod. So my pod is at present residing in default namespace. Both the pods are residing in default namespace. And that's the reason if I just give HTTP web, the name of the service, I'm able to communicate to it. So how does that work? Let's try and understand. So I have a web pod and I have created a web service as well. This is my web service. I'll just write it as W. This connection happens with the help of label and selector. And I have another pod created, which is my test pod. For this, I have not created a service. Only while the outgoing packet, the packet goes via the service. So I mentioned HTTP web. Web is the name of the service. So service name to service IP address translation would happen. Packet would arrive here, and from here it would go and reach the pod's IP address. And we are able to access our welcome to Nginx page. That is possible only because at present, no network policies are applied and default everything is allowed. So you can see here the welcome to Nginx messages there. So I'll just exit. So I had created 2 pods. Let's do get all and see our test and web, both are up and running. Now let's go ahead and apply that policy which we had seen, the deny all policy. So I have that file written over here. Let me just cat that file and show you the content. Here, web deny all is there. It is applicable to app web pods. So to create a resource, when you have a definition file, the command is kubectl create -f, and you supply the YAML file name so that it can pick up the definition from it. It has gone ahead and created the policy. You can go ahead and do kubectl get network policy. That's the name of the resource. So web deny all policy is created, which is applicable to app web. Let me clear the screen and come from the top in case it's not visible. So app web is the pod selector. Now the policy is applicable to the pod. It is attached to the pod which is running, the app web pod. Let's try and get inside our test pod again and try to reach our application of Nginx and see if it works. So my application is already running. The test pod is already there. So I'll do exec-it. I'll give the name and I'll get inside with sh. So how we have Docker exec-it name of the container sh is the starting process. I'm going with a secondary shell process inside that container. Similarly, in kubectl as well, we have the kubectl exec to create a secondary shell process and get inside your pods test container. So I'm inside that. Let's do a wget now and see if we are able to access the application. So we had done this last time and we were able to reach. This time you can see we are unable to reach the application because our application is not accepting any packets because of that deny all policy. I had not written timed out, so it kept waiting on it. So this is the policy which has enabled this because I have not specified anything. I have not specified which pod can communicate. That's the reason no pod can communicate at present to this web application pod. Now let me take you to the next snippet. Let me quickly clean up this screen. Now, if we look at the second sample, I'm not picking up the same example. It's a different example altogether. This is another policy, a kind network policy. The name of the policy is API allow. This is the name of the policy. On whom it is applicable. So this is, you can say on whom. I normally read like this. And from where. So if you ask this question on whom this policy is applicable and from where it can accept the packet, you would be able to understand this network policy file pretty easily. It is applicable to a pod which is having the label this. I've taken up an example here which has 2 different labels. A pod need not have just one label. A resource can have multiple labels, right? So here I'm having 2 labels, app, bookstore, and role API. So if I create a pod which will have app, bookstore as a label, and it should have role API as other label, then this policy is attached to that particular pod. Ingrace. Last time ingrace with empty square braces. This time ingrace has, in YAML, when we write hyphen, hyphen means list. That means I can have multiple of such elements. Sorry. Yeah. So here from you can see, it says from which pod can I accept the packet? From a pod which is having a label of app bookstore. So if there's another pod which is just having the label of app bookstore, the packet would be accepted. The packet would be accepted. And if I have another pod which is labeled as, say, app, for example, front end, this would be denied and this would be accepted because we are just accepting the packets coming from app bookstore. Let's try and see this. I had a graphical representation of these, but somehow I'm not that good with slides. So this is what we have done. Let me go ahead and show you. This is what we are doing now. So here we have app bookstore and role API. This particular pod is having app bookstore and role frontend. So the policy is applicable to this. The policy is not applicable to this despite it has that label of app bookstore, because policy would be applicable to the pod which will have both the labels. So policy is applicable to this pod and no other pods. This pod doesn't have app bookstore. It has app coffee shop. That's the reason it will not be able to communicate. Let's see this in action. So I'll go ahead and create a pod first. Let me clear the screen. kubectl run. I'll create the pod name bookstore. I would again use Nginx image. I can write equal to as well. I can give a space and write. This time, let me write the label spelling correctly. App bookstore. And I have another label. So I'll just put a comma, give the second label as role API. I would go ahead and create the service as well. I'll specify the port number as port 80. So here it's going to create this particular pod. Let me do kubectl get all and see. So pod and the service both are created. This is the pod and this is the service. Amazing. Now, let's see. I have this particular YAML file, which has that definition. So I want only specific pods to communicate. I'll go ahead and apply this policy, kubectl create -f. And let me just go ahead and copy and paste this. Policy is created, kubectl get network policy. You should have two policies now. One is applicable to this one, and the other one is applied or attached to the pod with app bookstore and role API. So policy is created and attached. It's time to test. Let's go ahead and test. So I'll get inside my test pod. So let me pick up my command. Yeah. This pod doesn't have label of app bookstore. This didn't have that particular label. It was a plain pod without any label. I just used an Alpine image, named it as test. There was no label attached to it. So I tried to do wget. The name of the service was bookstore. So I'll just say bookstore. It's not reachable. So bookstore pod is not accepting the packet coming from test. And that is what it is expected to behave as. Let's create a pod which has label of app bookstore. So I'll go ahead and modify this command of mine. I don't want to create a service. I'm picking up basic Alpine image and name it as, say, test test2, and I would give sh. Okay, I should have given -it as well. Normally I write it at the front, so let me write it there. So we also use --rm sometimes when we want to exit from the pod and get the pod removed as well. So that time we can use -rm. Let me use that. So I'm creating a test2 pod with the Alpine image, which would have label of App Bookstore, and it has the shell as the starting process inside it. Let's get inside the pod and try accessing this. So welcome to Nginx page is accessible from a pod which is labeled as App Bookstore. And my page is not accessible from the pod which is not labeled as App Bookstore. That means this policy of ours is making sense. It is applicable. It is not allowing from here, and it is allowing from here. So that's what it is expected to behave as. So these are two simple stuffs. A pod selector is used here. Like that, we can use even something called as namespace selector. So we can deny traffic coming from other namespaces as well. We can go ahead and deny traffic coming from different namespaces. We can use this namespace parameter. You can see here. The first, when we say metadata, inside that, whatever namespace is there, we know that in any type of YAML policy, YAML file, when we create any kind resource, when we don't specify the namespace in the metadata, it is meant for default namespace. So here we are going ahead and saying that this policy would be applicable in default namespace, and I would give the matched label condition here. And from whom it would be acceptable, not acceptable, that we would be specifying here. So I'll show you this file, and we would go ahead and deny traffic from other namespaces. Let's look into the YAML file. Let me quit from here. So test2 would be deleted because we have given --rm. So we have test, web, and bookstore pods. So app web is running, and I want to deny traffic coming from a different namespace altogether. So I have that file over here. Let me go ahead and open that. So here you can see it is showing pod selector match labels. It is empty. And here also it is specifying this empty curly braces from this. So it is denying packets coming from other namespaces. Okay. So this way you can go ahead and create policies which would help us in denying from different namespaces. We are actually a bit delayed in our schedule, so I'll go ahead and show you a few other policies instead of running them. Rather, just showing up the definition files would be helpful. This is another way of defining a complicated policy. You can see here, last time we just had a single section under from. In this, we have 3 sections. I mentioned wherever you have hyphen, that is like a list. I can have similar elements like that in that particular list. So this actually takes up as, let me pick up the, this actually takes up the OR condition. It is OR condition. So OR condition means I would be going ahead and doing an OR of the conditions. My pod's label should be this, or this, or this. Then you accept the packet. So if I have a pod with bookstore and DB, I have another pod with bookstore and search, this one. I have another pod with bookstore and API as the label, and another pod with inventory and web. Then they can communicate But if I have a pod which just say app bookstore, it will not be able to communicate. So this way we would be going ahead and doing a or and a and of the policies as well. This is or way of doing it. Same way, I have a sample for the and as well. Let me go ahead and bring back my mouse. I think this is the one. Let me give it a try. Yep. So here you can see there is one hyphen, but two different conditions are specified inside this. So this particular condition means that I would apply the policy to this pod labeled as app web, and it would accept ingress packet from a pod whose namespace label is team operations and pod label is type monitoring. So here and operation is done because we don't have hyphen here, you can see. So when we have a single hyphen on a two conditions, those two conditions would be and. When we have multiple hyphens, those conditions are odd. So the pod which belongs to this namespace and it has this label would be able to communicate to app web. In this particular namespace, if I have a pod which is labeled as, say, for type, logging will not be able to communicate. If type monitoring pod is there, but it is there in a different namespace altogether, then it would not be able to communicate either. So this way we can write even complex network policies and we can limit the communication to our pods. So that is what I had captured here. So many times we use different types of CNI. We have Calico as our CNI. Then we can even use Calico network policies. Calico provides you can say an add-on type of thing. You can define your Kubernetes network policies, plus you can have Calico network policies as well, which will give you more flexibility of defining ingress and egress rules. In Kubernetes network policy, we only define allow rules, but in Calico, we could also specify deny type of rules, and we can use different types of combinations of rules when we create. You can have more mix and match in those rules. And in our Kubernetes network policies, those policies apply on the pod. But with Calico, we can apply the policies on the host machine. We can apply the policies on the pod. So many a times what we do when we are actually working in a production cluster or a real-time cluster, pods, the Kubernetes policies are given to the developers. They would be applying those policies on the pod level. And the security guys or the administrators, those who are there in the Kubernetes cluster, they would be applying these Calico policies for securing the network on the host machine and on the virtual machines which are running as host on a specific interface as well. You should be able to attach these policies. So these policies are segregated in two types. One is Calico network policies and one is global network policy. When we say network policy, it would be applicable to a specific namespace, to a specific set of resources to which we apply. When we say global network policy, then it is not on a specific namespace. It's on the entire cluster level. It is independent of the namespaces. So the kind is a bit different here. You can see here kind is network policy and here kind is global network policy. I'll just show you some of the samples here. This is the sample. Here, kind network policy, the name of the policy and the namespace it is applicable to. The selector says on whom it would be applicable to the pod, which would be labeled as color red. Ingress, allow action, accept TCP packets from the source which are having this particular label, and the port number is also specified. So if the packet is coming from a pod which is labeled color blue, and it's coming on 6379 on a pod which is labeled as color red belonging to production namespace, then only this policy would accept, like allow to accept the packet. Here you can see we have used the namespace selector as well. So we can even go ahead and do, this is the AND condition. You have pod selector as color blue and namespace selector as shape circle. So this way we can define complex policies and have various different types of combination and limit the type of traffic which comes in our cluster to any of the applications. So that was all from my side today. Hope you people enjoyed the session.